Hello, my name is Carlos, and I am the discussion board lead for this week's topic. We are currently in week 10, and our title for this week is Logic is Not Dry, which is kind of funny as we are going to be working with a dehumidifier. So, for this week's problem, we are going to assume that we were hired by Samsung to help them design a new dehumidifier. The device removes excess moisture from the air to produce a more breathable environment. So we would be working on building the logic gates needed to activate the device. So there are conditions that must be met to activate the dehumidifier. So here the three conditions are displayed. So first condition would be the air humidity in the room must exceed 20%, but the container that holds the captured moisture must be less than 3/4 of full. When the override button is pressed, the humidifier will turn on regardless of the humidity and the volume of the captured moisture in the container. So for the first question, we need to follow the three simple propositions that are displayed below. And we need to identify and define the three conditions as the propositions P, Q, and R. So for P, we have humidity greater than 20% would equal 1. Also, humidity less than 20% would equal 0. For captured moisture in the container would be less than 3/4 would equal 1. And captured moisture greater than 3/4 would equal 0 for Q. And for the last condition, we have the override button pressed would equal 1 and override button unpressed would equal 0, and this would be the R. That being said, we for the next question we would have to write a truth table that shows the possible states of each of the three conditions and the outcome. So here we have the table PQR and its output. So how I tackled this was looking by the R as it is the condition of the override. So every time the R is equal to 1, it would give an output of 1, which would mean that the humidifier would be on. So here we show 1, 1, 1, and 1. So here we show that it's on for each of those conditions that are met. So after reviewing all those conditions, I went ahead and verified P and Q. So for P and Q, it would output 0 since it's 0 and 0. For the PQ here for 1 and 0 and 1, it would be 1 due to the R override. So the only time the P and Q would trigger the dehumidifier to turn on is when P and Q are true. So here we show 1 and 1, which will turn on that dehumidifier without having the override. So here we have the Minturn expansion for the truth table. So here we see P and Q are zeros and R is 1. So as I stated in the truth table, every time the R is 1, it's when the dehumidifier is triggered for on. The only occasion where P and Q would trigger the dehumidifier to turn on is in this case here. So now that we have the Minturn and the truth table, we are able to draw a circle, which is our next question. Here we have P, Q, and R as our outputs. Here I have displayed 1, 1, and 0 as one of our only occasions where P and Q would trigger the dehumidifier to turn on or off. Here we display the 1 as on. And here we have all the interns as AND gates. So here I have recorded a little video of the circuit in action. I'll display it here. So here we have Q as 1, which is still 0. I have P as 1, this is still 0. P and Q are triggered as 1, and we have the dehumidifier on. So we turn both of those off to verify the R would trigger the dehumidifier by itself. And here we see that it is true. The dehumidifier is on when the R is triggered. So for our next question, we were asked to use a K-map to reduce the circuit from 3. We had to redraw the circuit and have to determine how many gates we used once it was simplified. So here in the K-map, we have Q and R on the top, and these are P values. So here I have the circuit, which is an OR and AND gate. So here the input I have here is 1, 0, 1, which in the K-map we can see here this QR. This is Q, this is R, so that matches here. And for P, we have 1, which would trigger the dehumidifier. So here we see we use 2 gates instead of using all those other gates in the unsimplified version. So here the logic of this circuit was an OR gate. So the OR gate would give an output of on if the P and Q give a 1 through the OR gate, or R would give a, or R if R is 1, the OR gate would output 1. So in this case, the AND gate to output 1 to the OR gate, the P and Q would have to be 1 for both of the P and Q to be able to send the 1 through the OR gate. So here we have displayed the version of the circuit where R is overriding the P and Q due to P and Q not having each 1. So here we have 1, 0, and the AND will give an output of 0, thus not triggering the dehumidifier. But since R is 1, we go through the OR gate and it gives out an output of on. And for our last question, we had to verify the circuit was correct and compare the 2 truth tables to the one we had previously completed. So here we have that is true, and it did meet the correct truth table as the other one we had completed previously. So here, if you guys have any questions, you can direct them to me via Canvas inbox. If that is not viable for you, you can send me your email, phone number, and we can set up a Zoom, or we can talk through Discord about this problem and help you further understand it.